So I can pay for my children to go to college. All right. All right, let's get started. Make sure you're ready. Make sure you have this out. All right, let's put away the physics. Okay, so we're going to be looking at finding a 90% confidence interval for the population proportion. Remember, see this letter P? That letter P is the population proportion. That'd be the proportion of all of the residents in Polk County who speak 4 languages. So we're going to first write down the formula we used yesterday, which was P hat plus or minus Z star times the standard error of P hat. Does anybody remember the formula for the standard error of P hat? Very good. P hat times Q hat over N. Yes, Sebastian. You will be given this for my tests, my quizzes, but no, you will not be given, this will not be given to you. All right, they give you a generic form, so you're going to have to know it. All right, they will give you this in a PQ over N inside the square root, so they will, in theory, give you this. Okay? All right, so let's write down what we do know. Right, our number of residents. How many total residents did they sample? 1,000. How many successes? And let's first ask ourselves, what is a success here? What is a success? 4 languages. It doesn't say less than 4, more than 4. It doesn't say like 3 or 2. It just says exactly 4. So in this case, 6 is going to be our number of successes. Okay? So to find P hat, I'm going to do the number of successes over the sample size. So if you need the calculator, you can do it. I'm hoping that you see that the denominator is 1,000. So this would be 0.006 because we're in the thousands place. Remember to stop me if you have any questions, okay? All right, so I'm going to plug in that P hat of 0.006 right here. Okay. Do you guys, we haven't done this yet. This is our first 90% confidence interval. Do you remember the Z star that you're going to need to memorize for 90%? 1.94. That would be if it was 95%. 1.645. Very good. 1.645. Okay. All right. Start memorizing it. Let's plug in. Excuse me?
You just remember.
I am not going to give you the 1 point. But in the number 2, Abasi, on this one, number 2, I'm going to show you how to find it if you forget. Okay. All right. So if P hat is 0.006, do you remember how to find Q hat? 1. Subtract from 1. So that's going to be 0.994. Again, if you're like, well, how'd you get that? Just subtract it from 1. Okay. All over 1,000. All right, so if I wanted to, I could go in my calculator and multiply these. All right, I'm going to do the square root of 0.006 times 0.994 divided by 1,000. And what did I just calculate? Very good. The standard error of our sample proportion. So 0.002. I'm going to write the rounded number, right? But if I wanted to calculate the margin of error by hand, exactly, I'm not going to be using the rounded one. But I'm going to pause for a second. All right, I'm going to pause and transition to using the calculator function. All right, I showed you guys this yesterday. Over to test, exactly. So if you haven't turned it on yet, turn your calculator on now, because this is what you're going to do on these questions, okay? So hit stat, over to tests. Do you remember what letter it was from yesterday? A. Very good. 1 proportion Z interval, so letter A. So Cameron, this is so far the only one we've done so far. What you missed yesterday was a 1 proportion Z interval. That's the only one we've done so far. All right. Hit stat, over to calc. All right. Our number of successes was 6. our sample size, 1,000. And then this one I do have to change because it's not 95% confidence level. It says to run a 90% confidence interval, so put 0.9. When you're ready, hit calculate. And that's all you have to do because this is the interval, right? It's there. The reason I wanted to show you this is because I'm going to write it down, 0.00198. Is my low number. And my I'm leaving a space here, sorry. Leave a little space here. My upper number on my interval is 0.01002. So here's what I'm going to show you. If you take one of these numbers, can somebody pick one? Which one do you want to pick? Okay, we'll pick the first one. If you take that number, so 0.00198, and subtract your p hat, what was our p hat? 0.06. If you subtract that, this is called the margin of error. Ignore the negative, right? This is called the margin of error. So this is exactly. So that's why I left a space to put 0.00402. So if I had done all of that multiplying in my calculator, I would have found the same thing. All right, but you can do it. I mentioned this yesterday. It frustrates me that it doesn't give you that number. All right, but you can find it. All right, if you take one of your pieces of your interval, either your first one or your second one, right, and subtract the p hat, and you'll find it. All right, now on IXL, what you're going to type in is you're going to type in, since it says round to the nearest thousands right here, right, you need to make sure that you type in 0.002, right, because this is the thousands place, so that 9 will make it a 2. And this is going to be 0.010. Students will ask, do I need to put that other 0 at the end? You do, because you're rounding to the nearest thousands place, so you need a number in the thousands place. So this is what I would be typing in to IXL. Any questions on the process? What I just circled. Because it says right here, Nate, to round to the nearest thousands. So go 1 after, so tens, hundreds, thousands. Go 1 past it, the 9 makes that 1 into a 2. Go 1 past it, that 0 keeps this as a 0. If you're having trouble rounding, I'm going to give you 20 minutes to practice in a moment. I can help you with the round. Ready for number 2? Yeah. Okay, flip it over. Number 2. All right, so this one's going to have a little bit of an extra twist. Again, you don't actually have to do this on the IXL link, but I do want to show you because Abbasi said he's not going to memorize those Z-stars. So what is our sample size for how many people they randomly selected? 475. In terms of this one, the success is a caller did not have to wait on hold. So how many did not have to wait on hold? 67. So let's find p hat, which is 67 over 475. I do not know that one off the top of my head. 0.144. Right, so again, did I just round that? Oh, I did it wrong. I'm sorry, Taylor. My bad. Pushing buttons is hard. 141. What I'm going to say, oh, look at that. What I'm going to say is it still applies. What I'm going to say is I rounded, right? So when I do all this work by hand, is it going to necessarily be exactly what the calculator is going to spit out to me when I use the function? It's not. It's going to be close, but it's going to be slightly off. So I do all this with my work, but then I always use the calculator function to get the exact interval, especially with something like IXL, where you know they want the exact thing. Okay? So we're fine to round it right now, but when I do my answer, it will be not rounded. Okay, so let's write down the formula. Same formula. All right, so I'm going to write down my p hat, which is 0.141. But the moment I try to write z star, I don't know it. I do not have the z star for 99% confidence level memorized. I don't expect you either. So I'm going to show you right now how to find it, okay? So here's how you find it. a little further down, so leave a little space because we're going to do some more work, kind of near the bottom of your paper, draw the normal model. Doesn't need to be big, right? It can be a small one. All right? And I want you to make this, which is essentially our confidence interval. And what level of confidence are we doing for this problem? 99. So throw a big 99% there. So if you think of this as a giant curve, and I'm telling you that that interval is going to cover 99% of that entire curve, how much is left in terms of the percentage of that curve? 1%. Very good. And if you notice, on the left side and the right side in these tails, we've got two areas. So take that 1% and divide it in half. What do you get? You get 0.5%. And I taught you guys last semester that if you know the area to the left of whatever this z value is, this z-score is, we can use the calculator to find it. So that's how you do it. All right?
So would this help us just for 99 or can it
Any of
help
them.
us to like any?
Exactly. So like you could throw 95 up here, then you have 5% between the two of them, so this would be 2.5%. So you can. So if you forget, you can figure it out. All right. So let me show you what I mean. So if you have your calculator, hit second vars, then go to inverse norm, which is number 3. Inverse norm, which is number 3. Remember, for area, right? I have two options here. The easiest one, the one I teach students to do, is I'm finding this z-score. What is the area to the left of that? 0.5%. But as a decimal, I would type 0.005. That is 0.5%. Okay?
So it wouldn't be 0.5.
It wouldn't be 0.5. You got to change it to a decimal. So you got to make 0.5. So you'd have 0.5 right here.
Because it's still in percent, yeah.
Exactly. You got to move it over 2 places. That's why I wrote 0.005. Sorry, Nate, go ahead. That was your question? Okay. Now, if you wanted to, right, because what you might notice is that this one here is going to give me my negative z-score value. Do I actually care, though? I do not, because remember, what am I going to be doing in this formula? Adding and subtracting. So it doesn't matter. So I tell students, find it like this, and then just ignore the negative. All right, just take it off. But if you wanted to find the positive, you'd have to find this one, right, this one, which would mean how much area is to the left of that? 99.5%. I'll do it again. How much area is to the left of that? 99.5%. So you would type in, if you typed in, if I cleared this, and you typed in 0.995, you get the exact same number that we're about to get, but yours would just say positive. So it really doesn't matter. All right? I teach students to just do the one that's to the left of the number on the left, so I'm typing in that. All right, if you scroll down to paste and hit enter and do it, this right here, again, I'm ignoring the negative, is my z-star for 99% confidence. So you can always do this to find it. Did I do something too fast? I'm sorry. 2.576. Go ahead, Nate. Do you have a question? You want me to do it again? Okay. Second vars. And then number 3, which is inverse norm. And then you're ready to type in the area. That's it. Then you'll scroll down to paste and enter.
Or the U? No, what is it called?
The mu?
The mu?
Or the sigma?
Yeah. And then the O is always going to be 0 and 1.
Yeah, you're going to leave mu and sigma as 0 and 1.
Okay.
Right? A few students recognized when we did a Delta Math link in the first semester that you can change these if you're doing a problem that it gives you them, and then you don't have to do any algebra. It'll spit out the answer. But I teach you to find the z-score. All right, everybody okay on that? All right, let's find the standard error. So that's going to be the square root of p hat times q hat over n. Plugging that in, I have 0.141. And then what is going to be my q hat? 0.85. Exactly. Subtract it from 1, all over 475. Again, some of you are already recognizing you don't actually have to do this to get these right in IXL. I'm just trying to be consistent with the work that we did yesterday. Again, will my answer be exactly the standard error? No, because I did round 0.141. So this standard error of 0.016. So the standard error of 0.016 is obviously not going to be exactly correct. Now I'm going to go to my calculator function, right, to get the exact answer, and then use that strategy I just showed you to find the margin of error. All right, so you're going to hit stat, go over to tests. So stat over to tests. The only one we've used so far is letter A, which says a 1 proportion Z interval. Hit enter on that. Our number of successes is 67. How many people did they randomly select? 475. And what is our level of confidence? 99%, so 0.99. Go to calculate. And this is our answer, 0.09991. And then the other one is 0.18219. Which one do you want to use to find the margin of error? The one with a bunch of nines? Okay, sure. So 0.09991 minus our p hat of 0.141 gives us 0.04109. Okay. So I chose this one. If you subtract p hat, that will give you the margin of error.
So it doesn't matter which one we choose.
I'll do the other one right now, right? 0.18219 minus 0.141. It will give, obviously, one's positive, one's negative, but again, I ignore the negative. What's up, Ozzy? Are you talking about this up here? What I'm saying is if I did this in my calculator, I would get this, but it would be rounded. So it probably would have been like 0.0411. Like it would be off like pretty far past the decimal, but it'd be off just a little bit. So I use the calculator to make sure it's not off. That is exact. This is it for sure. Okay. All right. Round to the nearest thousandths and we'll be finished. Yes, go ahead.
In the test, would you take points off and just do like 2.258600?
No, I would not. Like if you did, I would hope that you would not multiply by this though. You would multiply by the not rounded because that's in your calculator times 2.576. That's fine. I'm not concerned about it because again, Jose, at the end it would be off very minimally, right? Then where I'm going to take points off is if like instead of having 0.099 whatever, you had 0.24. That's way off. Right? I'm looking for like if I can see your work and it's close, you're good. Good question. Okay, so nearest thousands, right? Remember, I gotta go one place after, so tenths, hundreds, thousands. So what's this 9 going to do to that 9? Make it a 1, so it's going to be 0.100. And then the other one's going to be 0. What's this 1 going to do to that 2? Keep it. Very good. And that is it.